let's talk about some details about why CircuitPython is easier to jump into for somebody who's completely new than C and even, C with Arduino libraries, essentially. I mean, I kind of have a few things, although honestly, like I'm slowly learning some CircuitPython here and there. I'm so kind of coming from a C background that's what I go to. And so there are definitely some things about like, wait, what do you mean I can't do that? But then there are other things that are just like, oh man, I don't have to worry about like strings and string storage and pointers, and that's really kind of nice. So
Sure.
So, yeah.
That's a great question. So it's from a number of viewpoints. So it's nice to have different options on how to program something because you want to program it in what you're used to. And so definitely if somebody's knows C and is comfortable with that, is to not discount Arduino. I mean, especially if you use Arduino for something. And the background is where you and I have learned C first, and then it's like Python is something we have to pick up.
Yeah.
Versus in a lot of the educational settings now, somebody will likely learn Python first, and in their learning how to write programs, and then pick up additional programs from that, Rust or Go or maybe even go back to C. But in C you could, there's these little landlines that they'll probably say, well, what kind of arcane nastiness is it? This pointer, null pointer, what, things like that. So people might already be familiar with Python. That's one thing. The big thing, and I talked about the kind of fork of CircuitPython versus MicroPython. MicroPython is oftentimes similar to programming that Arduino is you write your code in editor, say like Thonny or something, and then the editor talks to the board, not over like a serial connection, does magic talk, and then the code's on it and it runs. Adafruit wanted a much simpler method, so it uses tiny USB and make sure that there's these flash chips, that you have enough flash memory, that most CircuitPython compatible boards show up as a USB thumb drive. And that simplifies things quite a bit. So you'll plug it in and you'll see some files already there. There's a code file, code.py is the standard Python thing, a library directory with some pre-built libraries, and then let's see, a log file and a couple things to make Macs not throw nasty stuff on it. So you could actually, copy any file you wanted on here. You don't have a lot of space, but I mean, it is like a thumb drive, but you copy your library code and you copy Python code, and if there's any changes to any of the code stuff, it automatically resets the board and runs it. Right. So there's that ease of putting it on there. There's no special FTDI cable or special JTAG connector or all these things that some of these programmers might be familiar with, but your average person says, I'm lost. That's not good.
Yeah, your average person says, well, why can't the computer just talk straight to the board without having another board in between it? That doesn't make any sense. Yeah. Yep.
And then a big thing that CircuitPython has done versus Arduino, and I know you're familiar with this, is the code, compile, load it onto the board, see if it works, and then reiterate that way. And there are cartoons where people are goofing off during the compiling time, because that can often take a lot of time. And back in the old days with the mainframes and stuff, you would compile, and then you would get your coffee, you'd go outside, you'd goof off, whatever you do. But there's no compile step with CircuitPython or MicroPython. I mean, it's an interpreted language. It is slower. That's a trade-off. But I mean, when you have faster chips that are just a few more cents than a 328 or something like that, it's like, okay, I will spend a little bit more money. The footprint's not anything, and I can have lots of benefits to go with that.
So okay, but what do you tell to those of us who the compiling step is our security blanket, right? It feels weird to not have that compiling step, because I feel like the compiling step like catches my errors before something bad can happen. Right? And you know, I know we're not necessarily like talking about anything earth-shattering here. We're talking about like little projects and things like that. But there is this element of the compiling step, like, oh, okay, it caught this, it caught that. It tells me what line I had the problem with. And then when my code does compile, it has a better chance of actually running the way that I think it should be running. So
Well,
how, yeah, I mean, I know
I would
that you
try
have the REPL that tells you where things are wrong, right?
the REPL, yeah, you can type some things into the REPL directly and get that interaction. But
yeah,
basically, when you copy the code over and it automatically runs, if there is an error, the code will stop and it will print out to standard out the REPL
mm-hmm.
what it didn't like. And it could
Yeah.
be as simple as a syntax error or missing this or that, just like we're used to, or it could be more complex. But the thing is, in Python being interpreted, you have control over a lot of the things that it catches. Now, if you have like fresh code and you're more of a professional developer, you have a project that's more important, there are tools. There's Pylint, and we use Pylint and a program called Black. Black is more of a formatting syntax checker, and Pylint checks for issues with the code.
Mm-hmm.
So everything that Adafruit does goes through those filters. So when it's put on GitHub, there should be a lot less chance that there's an issue.
Yeah.
You know, a syntax issue. I mean, obviously we can misspell something here or there and it wouldn't pick it up, but things like equal versus equal and things like that hopefully should be caught. But Python allows you to trap certain kinds of errors. You can say, try to import a library, and if that fails, do something else. And so, or you could try to open a serial port or try to open a file. And if for some reason there's an issue, then you can actually deal with it. And you can do some of that, you know, like C, you have files. If you can
set that up.
You can set that up. But I think Python, it's a lot easier, and it actually can extend into the code itself and how it interacts with whatever it's doing. It's pretty powerful, and you have control over saying, okay, there's certain times where you might ignore an error, but there's certain times where you want to do certain things on specifically what's happening. And in the embedded space, you do know that there's issues where the environment the hardware finds itself in may be different than what you expect. It may wake up and it's not on the deck ready to be deployed as a barnacle scraper. It's actually under the hull, and it just reset itself, and it's like, where am I? You can try to anticipate some of those and deal with it, or test your hardware and say, okay, I found an edge case, to be able to handle that elegantly or something like that. I think it makes it easier. And so, again, everybody's comfort's different, but if if somebody doesn't have to see a whole bunch of compiler errors and warnings, maybe you can actually get to coding it, and you say, okay, I'm actually making structural errors in my code rather than syntactic errors or something.
Yeah. There are a lot of good comments on this too about, that just the drag and drop method allows for very, very fast iterations. And so if you're doing some trial and error, that can definitely be faster. And
I've had people talk to me and say they've saved hours and hours of time in the and a lot of people code like I do. I mean, you start off doing something basic, and then you add more capability, and you hone in on exactly what you want it to do. It works.
Oh, and Bob spelled out REPL for us. Read, evaluate, print, loop, console.
Mm-hmm.
Yep. And Devin's workshop says that that Mu, which is a Python editor, and the IDE, that it takes place of compile errors and that it catches them instantly too, and that you can just think of when you save a file, that's like an instant compile. Yeah.
Yes.
And then thumbs up for Pylint and also CircuitPython extensions with VS Code.
Your development environment, no matter what you're doing, it has a big bearing on how well you can do it, how well you know the environment. Adafruit recommends Mu for beginning people because yes, it definitely it has all that handshaking, the USB handshaking with the boards baked in. Mm-hmm. It has the kind of Pylint capability built in, so when you say, hey, go ahead and download, it's going to say, no, you made a syntax error here. Something's not quite right or whatever, before having to go back to the board and then looking at the serial output and saying, well, something isn't working. It's not doing it right. But there are other tools. VS Code is wonderful for the more advanced programmer, and you're not limited to just Python, or it will do pretty much anything with the right plugins and settings, and so that's wonderful too, and a whole host of others.
Yep.